Hello everyone. Hope all you are doing well. Today I come up with another topic, DHCP. So have you ever thought how DHCP works in backend? Why we use DHCP? Let's start with one of the interesting topic, DHCP. First we will see what is the agenda of today's video. So in this video we will cover what is DHCP, how DHCP works, what are the main DHCP messages, what are the key components of DHCP and benefits of using DHCP, what is DHCP relay, why we need DHCP relay, how DHCP relay works, and why we configure DHCP relay. And we will see some configuration part of DHCP as well. So let's come to our first topic, what is DHCP? So DHCP stands for Dynamic Host Configuration Protocol, which is a network management protocol used to automatically assign IP addresses and other network configuration information such as subnet mask, default gateways, and DNS servers to devices called clients on a network. Basically, DHCP is a protocol used to assign automatically IP addresses to a client's, for example, computer. Before going to next slide, have you ever thought how DHCP works? First of all, don't learn things directly. Think, ask questions from yourself. If you are preparing any topic like DHCP, then ask yourselves how DHCP works in backend, what will happen with DHCP. Ask these kinds of questions from yourself, then understand the things. If you understand, then there is no need to learn. It will automatically fit in your mind. So let's see how DHCP works. DHCP works on Dora Process. Dora Process is a message exchange between a client and a DHCP server. Message exchange in Dora Process are discover, offer, request, acknowledgement. Now we will see what is there in Dora messages. So first, client send discover packet to the server. This message is to discover the DHCP server in your net. Means to find out where the DHCP server is located. This message is layer 2 unicast and layer 3 broadcast, and it contains fields such as source IP 0.0.0 because client don't have any assigned IP address. Then destination IP as broadcast IP 255.255.255.255, source MAC DHCP client's MAC address, destination MAC FF:/FF:/FF:/FF:/FF. Then server send offer message to the client. In this message, DHCP server offer available IP address that the server is willing to assign, along with other network configuration details, example subnet mask, DNS server, and default gateway. This message is also layer 2 unicast and layer 3 broadcast, and in this message it contains fields as source IP DHCP server IP address, destination IP as broadcast IP, source MAC as MAC address of DHCP server, and destination MAC as DHCP client's MAC address. After this offer message, client send request message to the server indicating that it wants to accept the offered IP address. This message also tells other servers that their offers are declined, ensuring the client only use one offer. This message is also layer 2 unicast and layer 3 broadcast, and in this message it contains fields such as source IP 0.0.0, destination IP as broadcast IP, source MAC as DHCP client's MAC address, and destination MAC as DHCP server's MAC address. After this request message, DHCP server send acknowledge message to this client. In this message, it confirms that the IP address has been assigned to the client. It includes other configuration details that client needs such as lease time and DNS settings. This message is also layer 2 unicast and layer 3 broadcast, and in this message it contains fields such as source IP, DHCP server IP address, and destination IP as broadcast IP because still IP is not assigned to the client. Then source MAC as MAC address of DHCP server and destination MAC as DHCP client's MAC address. Now we will visualize the DHCP Dora process. Now you will see this DHCP discover message from client to broadcast and contain DHCP broadcast a request for an IP address. Then DHCP offer from server to client. Then content DHCP server responds with an offer including IP address and other network parameters. Then DHCP request message from client to DHCP server and content client requests the offered IP address and the configuration. Then last, DHCP acknowledgement. DHCP server sends this message to the client, and content in this message is server confirms the assignment and deactivates the lease time. Let's come to our next slide. Now apart from these 4 Dora messages, we will see some other messages exchanged in DHCP. So these messages are DHCP NAC, negative acknowledgement, DHCP release, and DHCP inform. So in this DHCP NAC, this message is from server to client. If the server cannot fulfill the client's request, example, if the requested IP is unavailable, it sends a DHCP NAC message indicating that the client should try again or use another address. So in next message, DHCP release, this message is from client to the server when a client is finished with the IP addresses. For example, it is disconnected from the network. It sends a DHCP release message to inform the DHCP server that the IP address is now free to be reassigned. And last, DHCP inform this message from client to the server. If the client already has an IP address but wants additional configuration like DNS servers or subnet mask default gateways, so it sends a DHCP inform message to server to request this information. Now, what are the key components of DHCP? So in this DHCP server, DHCP client or lease time. So in DHCP server, the device or software that provides IP address and configuration information to the client. And DHCP client, any device, example computer, smartphone, that request an IP address and configuration information. And what is lease time? So the amount of time an IP address is assigned to a client. After this time expires, the client must renew the lease to continue using the address. जितने टाइम के लिए एक IP एड्रेस असाइन रहेगी क्लाइंट को, उस टाइम पीरियड को हम लीज टाइम बोलते हैं. Now, what are the benefits of DHCP? Like automatic IP configuration, efficient address management, and centralized control. So automatically IP configuration, in this, devices on the network can automatically receive their IP address and other necessary information, making network setup easier. And efficient address management, DHCP prevents IP address conflicts by ensuring that each device receives a unique address. And centralized control, network administrator can configure and manage IP address assignments from a central server rather than configuring each device manually. ऑटोमेटिक आईपी कॉन्फ़िगरेशन में क्या होता है कि जो क्लाइंट है उसको अपने आप उसको आईपी एड्रेस मिल जाती है और जो अदर नेसेसरी कॉन्फ़िगरेशंस इंफॉर्मेशन लाइक डिफॉल्ट गेटवेज डीएनएस सेटिंग वो भी उसको अपना मिल जाती है, तो वो सेटअप को इजियर कर देता है. और एफिशिएंट एड्रेस मैनेजमेंट में क्या है कि जो डीएचसीपी सर्वर है वो इंश्योर करता है कि हर डिवाइस को एक यूनिक आईपी एड्रेस हो. और सेंट्रलाइज कंट्रोल में क्या है कि हमको हर डिवाइस पे जाके मैनुअली कॉन्फ़िगर करने की जरूरत नहीं है. एक ही सेंट्रल सर्वर से जितने भी डिवाइसेस हैं उनको आईपी एड्रेस असाइन हो जाती है. नाउ वी विल कम टू आवर नेक्स्ट टॉपिक, व्हाट इज डीएचसीपी रिले. So DHCP relay is a network device or service that forwards DHCP message between client and DHCP servers when they are not on the same local network segment. This is particularly useful in larger or segmented networks where the DHCP server is located on different subnet than the client device. अब जो DHCP client है वो ब्रॉडकास्ट मैसेज भेजता है, जो डिस्कवर पैकेट है वो ब्रॉडकास्ट मैसेज होता है. तो अब ब्रॉडकास्ट मैसेज एक नेटवर्क से दूसरे नेटवर्क में तो जाएगा नहीं, बिकॉज ब्रॉडकास्ट इज विद इन अ नेटवर्क. तो उस ब्रॉडकास्ट मैसेज को दूसरे नेटवर्क में डीएचसीपी सर्वर के पास पहुंचाने के लिए हम डीएचसीपी रिले यूज करते हैं. वी कैन से डीएचसीपी रिले इज अ चैनल फ्रॉम क्लाइंट टू डीएचसीपी सर्वर. नाउ व्हाई वी नीड डीएचसीपी रिले? We need DHCP relay for subnet limitations and centralized DHCP server. Subnet limitation means DHCP servers typically send broadcast message to all devices in the local subnet. If a client is on a different subnet from the server, the broadcast will not reach it. A DHCP relay helps to forward these messages between subnets. And centralized DHCP server, in larger networks, it's common to have a centralized DHCP server that assigns IP addresses for all subnets, avoiding the need for multiple DHCP servers. Now we will see how DHCP relay works. So in this DHCP discover, client send this message to the server to discover DHCP server. So sometimes DHCP server is in another network and this message is broadcast. So in broadcast the packet will not forward to another network. The broadcast is in a one network only. So for this message DHCP relay agent help to listen this broadcast. Now second, forwarding discover. The DHCP relay agent help to forward this DHCP discover message to a DHCP server. This message is forward via unicast, means sent directly to the DHCP server. Now next, DHCP offer. This message is from server to DHCP relay agent, which is sent or relayed to the client by DHCP relay agent. Now next, DHCP request and acknowledgement. In this, client send DHCP request to DHCP relay agent and relay agent forward the request message to server. Then server responds with the acknowledgement message. Now we will see why we configure DHCP relay. So in most network devices like router or layer 3 switches, the DHCP relay agent can be configured to forward DHCP request to a specific DHCP server using the IP helper address command. This is a command used for DHCP relay in Cisco devices. For example, this command tells the router or switch to forward DHCP message to a designated DHCP server. Now we will see steps to configure DHCP server. So in these steps include Like first we need to enter the global configuration mode, then we need to define the DHCP pool, then we need to configure the network and subnet mask, and we need to define the default gateway and specify the DNS server, lease time, and exclude the IP addresses if we need, and activate the DHCP services and verify configuration, and then in last we need to save the configurations. Now we will see the commands to configure DHCP server. So in this you will see for the commands like enable, then configure terminal. This configure terminal command is for global configuration mode. Then we need to define the like IP DHCP pool and my pool. My pool is the name. We will give any name here. Then we need to define the network, and after that we need to define default router, and then DNS server, lease time, IP DHCP excluded address. This command is to exclude the IP, and then service DHCP to activate the DHCP service, and after that write memory is to save the configuration. So thank you so much for watching this video. I tried my best to make this topic easier and simple for you so that you can understand easily. Hope you understand what is DHCP. To see such kind of videos, subscribe my channel and keep supporting. Show your love on this video, like, comment, share, and don't forget to press the bell icon. For your doubts, you can comment your questions below. I will give you reply to your questions within an hour.